In this video, we're going to talk about TensorFlow name scopes and variable scopes. The reason for discussing these two concepts is because our neural network are going to become more and more complex. It's going to involve more and more neurons, and it's going to involve more complicated calculations. So when our neural network becomes really complicated, we will need more sophisticated tools that allow us to organize both the code and also the computational graph created using the code. So TensorFlow provides these two kinds of scopes, the name scope and the variable scope. And these two kinds of scopes allow us to organize things when dealing with really complicated neural networks. So let's try to create a name scope first and see the effect on the computational graph. And to do that, we first import all the necessary modules and we reset the graph. And then we're going to reset the default graph. And we've seen these two lines of code before. And to create a name scope with the name, say scope 1, we can use the name scope function provided by TensorFlow. So with, it's just like opening a session, but now we're actually opening a name scope. So we can also use the Python keyword with, right? And then tf dot name scope, it's a function. Name underscore scope, it's a function. And then the input, let's give it a name. Let's call it scope 1. That's going to be our name scope, the name of our name scope, right? And if you are going to use this particular scope inside of the with block, you can use as, say, scope, right? And then colon. If you are not going to use the scope inside of the block, then you can sort of just forget about this part, right? Just delete, just get rid of this part, right? We're not going to use it, but nevertheless, let's put this in there. Put this part in there just to show you the complete syntax to how to use it in this kind of context. And then inside of the name scope, we can create some TensorFlow variables. For example, v1 gonna equal to tf dot variable, and then let's give the value 1, and then name equals to v1, and then d type equals to tf dot float 36, right? And then that's v1, and then v2, let's just copy and paste this part of the code, and then v2, let's give it a different value and then a different name, right? So that's two variables, and then we can do some calculations to create a new tensor. So let's call it v3 equals to tf dot, let's just use an add v1 and v2, right? And then let's give it a name, let's call it v3, right? So the tensor v3 is obtained by just adding the variables v1 and v2 together. And when we have created the variables and tensors, so if you look at how I'm calling all the different functions, right? We have a keyword argument name. So it's name equals to v1, name equals to v2, and then name equals to v3, right? All those are keyword arguments that we have assigned to the variables, right? So if we would like to actually print out the names, we can just use Python print. Let's just do a print. Print v1.name plus the new line symbol v2.name plus, and then plus v3.name, right? So this dot name allows us to actually see those names that we have assigned to those variables, right? And then if we want to run it, we see this kind of printout for the three names: v1.name, v2.name, and v3.name. And we see that the names v1, v2, and v3 are exactly the same as what we have specified in those keyword arguments, in the name keyword arguments, right? It's v1, v2, v3. That's exactly the same, right? But in addition to that, we have a scope1 slash in front of it. We have a prefix of scope1 slash in front of every variable name, right? In front of all the tensor names, actually, right? So scope1 comes from where? Scope1 comes from the name of the name scope, which is scope1, right? So now all the variable names are not just going to be v1, v2, or v3 anymore. It's going to be prefixed with the name of the name scope, right? If you get rid of this line, suppose I comment out this line and then get rid of the indentation, and then suppose I reset everything. Right. Now let's rerun it. Then it's just a v1, v2, and v3. This scope1 prefix is created by this particular name scope. Right? It's because of this name scope we have a different name for the different for all the tensors, basically. So basically, it allows you to actually group together all the different names into one name scope. Now let's create another name scope. Let's call it scope 2, and then we can put some additional variables into this new name scope. So let's with tf dot name scope. Let's call it scope 2. Right, and then let's give a a1 equals to tf dot variable 2 name equals to a1, and then b type equals to tf dot float 2, and then let me create just one more variable a2, let's say 3, and then a3, a2, right. And then a3 is gonna be equal to tf dot multiply and a1 and a2, and then let's give a name. And also we can print out the names for all the variables inside of the name scope 2 scope 2, but it's a1, a2, and a3. So the tensor a3 is obtained by just multiplying variable a1 and a2, right? Here v3 is obtained just by adding v1 and v2, then we get v3. And here we're multiplying a1 and a2 to get a3. So we can also print out the names for all the variables inside of this name scope. Right? And finally, maybe let's try to create one more variable. Let's call it not variable b. It's a tensor, right? tf dot divide. We're just going to divide v3 and a3, and then let's give a name called b. Right? B is going to be the division between v3 and a3, these two tensors, basically. And then we can print b name. Right? So b is not inside of any of the name scopes. So if we run this piece of code, we're going to see v1, v2, and v3 are inside of the scope 1. And then a1, a2, and a3 are inside of scope 2. And the b is not inside of any name scope. Right? So if we want to just write the computational graph into a log file, we don't really have to sort of use a timestamp or any kind of sophisticated directory or file name construction. We can just let's do something that's looks like a shortcut. So writer is going to equal to tf.summary dot file writer, and then this file writer is going to take two inputs. One is the log directory, and then the other one is the graph, basically. So the log directory is going to, let's call it name scope 1. Right. And then the graph is going to equal to tf.get default graph. So we're just going to get the default graph to. So that's going to be our writer, and then once we have finished using the writer, we should just close it. Right, we should just close it. And we can run this code. Right, and it's supposed to create a log directory for us. So if I go to desktop, I'm supposed to see a namescope 1, and inside of it I should be able to see my event file. Right, and then at this point I can do tensor board, and then give it a log dir. That's namescope 1, and then I can just run it. And now I can actually open my browser to look at the graph that we just constructed. Right. Right. And that's the graph. That's the graph that we just constructed. Right. So the top node B, that's the division, right? That's the division operation that we created B by dividing V3 and A3, right? So this top node shows the operation associated with the division to obtain B, which depends upon V3 and A3, right? And the variables and operations for obtaining V3 and A3 are now being wrapped up, being grouped together into these two nodes. That's called scope 1 and scope 2. Right? That's the name of our namescopes, right? So scope 1 is our first namescope, and then scope 2 is our second namescope that we constructed in our code. And then if we sort of double click on this plus sign, we're going to see V1 and V2 inside of it. Right? That's inside of the scope 1. And the V1 and V3 add together give us this. V1 and V2 add together give us the V3. Right? And then V3 is being used for computing B. And then inside of scope 2, we're going to be able to see A1 and A2. We multiply them together to get A3. Right? It's a multiplication operation. And then A3 is being used for computing B. Right? So when dealing with really complicated neural networks, the graph can easily become cluttered with thousands of nodes. And in this case, we can create namescopes to group together those related nodes and reduce the clutter in the graph that's displayed in the TensorFlow, right? And it's going to make it easier for us to actually detect, to track down any kind of errors or any kind of bottlenecks in our graph. So let's get back to the code. So when we were actually discussing TensorFlow variables, when we were discussing creating TensorFlow variables in a previous video, we mentioned that there are two different ways for creating a variable. There's another way for creating a variable. That's by calling the getVariable function. So suppose we want to create a V1 by using that getVariable function. So let me comment out this line and then rewrite the code for creating V1. So tf getVariable. Right. And this getVariable is going to require a mandatory input for the variable name. Right. Let's call it V1. And then it's going to take an optional shape input and then an optional dtype. Let's just still put it as tf.float 32 for now, right? And then let's try to sort of create a new log file. Let's call it a namescope 2. Right? We're gonna create a new, a different log directory, just in case that we just don't want to mix all those different event files together into one log directory. Right? And then let's run it. right? We can sort of see from the printout that the name v1 is no longer prefixed with scope 1 like v2 or v3. For v2 and v3, both of them are still created by, v2 is still created by using the call to variable. It's not the call to get a variable, it's call to variable, right? And v3 was created by adding together v1 and v2. So both v2 and v3 are still prefixed with scope 1 slash. But v1 is different. Even though v1 was created inside of this with group, it's inside of this name scope, right? But v1, for some reason, it's not prefixed with scope 1, the name of the name scope anymore, right? So if we want to sort of look at the new graph, if we want to look at the new graph, we can do that, right? We can do that. Let's take a look at the new graph, but let me sort of stop this one. But it's name scope 2 now. Name scope 2. But let me reload this particular graph. So you can see that the variable v1 is no longer inside the scope 1 anymore. It's actually coming out already. It's coming out. So scope 1 is only going to contain v3 and v2 and v3. Right? v1 is still going to we're still adding v2 and v1 together to get v3. Right? This is still an add operation. Right? But v1 is no longer inside of the node for scope 1. Right? It's outside of it. It's outside of it. And that's sort of the effect of using a get variable, right? By calling get variable, you're actually putting v1 outside of the name scope 1. So if a variable is created using the get variable function, right? Like v1 here, the only way to place this variable inside of a particular scope is to actually change the name scope to a variable scope. So now if we actually replace the name scope function with the variable scope function, let's comment out this line, but replace it with a different call. Right? If we change the name scope to variable scope, right? It's a different function. So name scope is underscore scope is a function, and then variable underscore scope is a different function, right? Then this variable scope is going to create a different different scope for us, and it's a variable scope. It's not a name scope anymore, right? And then let's also change the printout, the log directory. Let's change it to variable scope. Variable scope 1. Right. And that's all the changes we want to make for now. Right. And then maybe let's do a reset. Let's do a reset in the console, and then we can rerun the code. And now you can see v1, v2, and v3, all of them are prefixed with scope 1 now. But you have to recognize that scope 1 is no longer a name scope. Scope 1 is a variable scope, right? Because the scope 1 is created by calling the variable underscore scope function. So v1 is again inside of scope 1, but the scope 1 has changed from a name scope to a variable scope. Right? And again, we can sort of look at this graph in TensorFlow. Let's just quit this one, and then change it to variable scope 1. And then again, let me reload it. Right. So now variable 1, v1 has gone back to the name scope now, to scope 1 now. Scope 1 now. Right. So v1 and v2 are both inside of the scope 1 node. Right. Scope 2, we didn't change anything to scope 2, so scope 2 is still going to look the same. And the variable scope, for now, it looks like it's pretty much the same as the name scope, right? You just put a prefix onto the variable name and then move variables in and out of a certain node. That's kind of a representative. That's used for representing the entire the entire scope, right? Looks like the same thing, but they are actually not the same thing. The variable scope, in addition to grouping together different nodes, it also has a second utility, right? It has a very important utility, which is actually the variable scope allows us to share the content of a variable at different parts of our code. So if you have done any kind of programming before, if you have used any kind of computer language or programming language before, the conventional way of sharing data among different parts of a code is to actually create a data structure to store that information first, and then just pass that data structure as an input parameter to other programming units, for example, functions, right? In Python, you can do the same thing. You can just create the data structure first and then pass it around as input parameters to other functions or to other methods. And in TensorFlow, there's another way of sharing data, which is actually through the variable scope, right? The variable scope actually provides a different way for sharing data among different components of our code. So in TensorFlow, the variable scope is actually used very often to share data, right? It's not really, you can still do the conventional thing. You can sort of construct a data structure, put the variables in that data structure, and then sort of pass that data structure around. But in TensorFlow, the approach that's used more widely is by using the variable scope to share data. So now let's see how that's going to work, right? We're going to try to share the variable v1. We're going to try to share the variable v1 among two different name scopes, right? So let's still change this scope back to a name scope instead of a variable scope, right? So we're going to change this block of code back to a name scope, right? So this, we're still calling the name scope. This variable scope call has been commented out, so we're still calling the name scope. And then inside of this name scope that's called scope 1, we're going to create a variable scope. Let's create a variable scope. And then let's just call it VS1, right? Variable scope 1. Let's just call it variable scope 1, right? And if we want to use the variable scope inside of the block, we can put it as VS or something like that, right? But if we don't want to use it inside of the block, we can just put a colon here, and then we can just indent v1, to make v1, to make this line a line inside of this width block, basically, right? And now if we would like to reuse the content of v1 inside of the name scope 2, right? So that's our second name scope. That's the scope 2. We want to reuse v1 that's defined in this particular variable scope that's called vs1, right? So if we want to do that, how are we going to do that, right? How can we do that? So suppose we want to replace a1 with v1 basically. We want to replace the content in a1 with the content in v1, right? So we're going to redefine a1 basically. We're going to redefine a1 so that a1 can be exactly the same as v1. So with tf dot variable scope, and then the variable scope that I'm using here is going to be exactly the same as the variable scope that I created here. Let's still call it vs1. And then the variable scope function takes a second optional input. We can use it as a keyword argument. So reuse. We set reuse equals to true. Which means what? Which means we want to reuse the variable that's defined in this particular variable scope, vs1. And in this variable scope, vs1, we have one variable there. That's v1, and it has a name of v1. Right? So in principle, we have a variable that's called vs1/v1. And here we are saying that we want to reuse this particular variable scope that's called vs1 because we have set the reuse to true. Right? And then inside of this thing, inside of this with block, we're gonna redefine a1. A1 is gonna equal to, instead of calling variable, we're gonna call get a variable this time. And then the mandatory input, we're gonna give it a v1. The mandatory input for the variable name, we're gonna give it v1. Right? So here, instead of creating a completely new variable a1 by calling the variable, we're actually placing a1 inside of the variable scope, that's vs1, with the reuse keyword argument set to true. But the most important thing here is probably the call to get variable. This call to get variable, what exactly is it going to do, right? What exactly is it going to do? So first, the reuse argument, the reuse keyword argument set to true means that when I call the get variable function, I want the get variable function to search this variable scope vs1 first and try to find the variable name v1 inside of this variable scope first, right? And if it finds this variable name, it's gonna return that existing variable inside of this variable scope, right? If it doesn't find this particular variable inside of this variable scope, then it's gonna try to create a new one, right? That's what the get variable function is gonna do when you actually set the reuse to true, right? So the call to variable is always gonna create a new variable, right? But the call to get variable is gonna do a search first. If it finds v1 already in the variable scope, then it's gonna return that variable inside of this variable scope, right? If it doesn't find it, then it's gonna create a new one. This is a kind of fundamental difference between variable and a get variable, right? It's a very important difference. And to make sure that this a1 and v1 are indeed the same, let's add one assert statement. Right, let's just assert a1. We're gonna compare with v1, right? This kind of a double equals to means comparison, right? So if this comparison evaluates to true, then this assert is not gonna print out anything. But if it evaluates to false, then it's gonna print out a string. Right, the string that it's going to print out is a1 and v1 are different, right? So if this condition evaluates to true, then assert is not going to do anything. It's not going to print out anything. But if it evaluates to false, then it's going to tell us a1 and v1 are different. Then it's going to do this print, right? And again, let's put the graph into a log file, but let's change the log directory to variable scope 2, right? And then let's do a reset. And then we can just let's try to rerun the whole thing. And then now let's look at the screen printout, right? Let's look at the screen printout. So for the variable v1, the prefix now is not scope1 anymore, it's vs1. vs1 is the name of the variable scope, that's vs1, right? And then for v2 and v3, the prefix is still scope1, that's the name of the name scope, right? And then for a2 and a3, A2 and A3, the prefix is still scope 2, right? That's the same thing. But for A1, A1.name, it has been changed to be exactly the same as the name for V1. It's also VS1 prefix, VS1/V1, right? That's exactly the same. So the name of A1.name has been changed to VS1/V1, right? And the assert didn't actually print out anything, which means what? Which means A1 is indeed identical to V1. Right? In Python, you can check the ID of any kind of object by using the ID function. Let's just call ID function on A1. Right? It's going to give us a unique identifier. That's for every object in memory. Right? It's unique for every object in memory. So if I do ID V1, you're going to see that these two numbers are exactly the same. Right? Which means both name A1 and V1 are actually pointing to exactly the same memory, exactly the same object inside of the at the same memory address. Right? And if we examine the graph inside of TensorBoard, so again, let me switch to a different log directory. That's variable scope 2, right? And then let's reload the graph. And that's our new graph, right? So we're gonna see VS1, that's the variable scope, right? This variable scope actually contains V1. So V1 is inside of the variable scope, right? And this variable scope V1, that's inside of VS1, is shared both by the name scope 1 and the name scope 2. These two name scopes. You sort of see the arrow that goes into both scopes. Right? And if you sort of double click on scope 1, you're going to be able to see that. So V1 goes into scope 1 and then do this addition with V2, we get the V3, right? And then inside of scope 2, in the previous graph, we have an A1 node here, right? We have an A1 node here. That A1 node is going to do a multiplication with A2 and create A3. But now that A1 has been replaced by V1. That's from VS1. So A1 is basically the same as V1. And we are using that, we are reusing V1 to as A1 to do a multiplication with A2 and then obtain A3. Right? And you can sort of see how this variable is being shared by these two different name scopes. Right? And it can also be shared among different functions. Right? Among different functions, variables can be shared among different code blocks. Right? So we're going to look at more examples in the next video.